Thank you. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to the session of Geography, where today we shall be furthering and continuing our discussion for geomorphology. Now, yesterday we had discussed about the concept about the formation of planet Earth. How is it that the planet Earth did actually come into existence? We did talk about the entire process of formation, which happened around 4.5 billion years ago. And also, we looked at the concept when we talk about the evolution of the planet since its time of formation to the present day. How is it that the planet evolved? We looked at even the giant impact hypothesis, which tells us about the formation of the moon. Then, after that, we looked at the interior structure of the planet Earth, including the direct and the indirect sources, which help us understand and which make us aware about the interior of planet Earth, the structure of the interior. We looked at the various different sources of information, such as asteroid, meteorite impacts, the gravitational and the magnetic field anomalies. Then we looked at the various different layers, their properties, as well as we understood the concept of discontinuities. What are the various different discontinuities? Then we observed the aspect of geomagnetism. And with the help of geomagnetism, we basically first of all understood why is it the case that planet Earth actually subtends its magnetic field and what is the impact of it. We also looked at the fact that the magnetic poles across the planet, they keep on changing, and it is not permanent, it is something which keeps on varying. And that is something which also impacts what we refer to as the auroras, the northern and the southern lights which get created in the higher latitudes. That is again something that we looked at. Today, we are going to talk about first of all, we are going to initiate the discussion with the basic concept of rocks, the classification of rocks, on what criteria are the rocks classified. Then we shall be picking up the concepts of continental drift theory, the convection current theory, the seafloor spreading theory, and eventually all of that which leads us to the plate tectonic theory. So today's portion is going to be very important for the point of view of both your prelims as well as the mains examination. From the portion of the rocks, here in prelims, you can expect questions about the basic classifications of rock types, and in the mains examination you can expect questions basically about the aspect of the basic features again of rock types, along with the concept of rock cycle. So, in the portion of rocks, these are the areas from which questions can always be asked from and have been asked from this particular area. Now, rocks are something that we encounter on a day to day basis. When we talk about rocks and the types of rocks, the various different categories, and in various different places, the different types of rocks that we end up finding, we basically observe that there is a variation. Not all the rocks that you would have seen around you, not all the rocks appear to be the same. There is a variation which does exist. So, here we will try to understand what that various types of rocks are. So, rocks, when we see rocks in general, they are not always going to be uniform in terms of their appearance, in terms of either their shape, their size, or even in their composition. The rocks are made up of various different types of minerals, various different types of aggregates, and they solidify many of the times, and that leads to the formation of the rocks. Now, the entire region of the crust is composed of very hard rocks. So, here, when we talk about it, so basically, rocks are mineral aggregates with a combination of properties of all the various different mineral traces which are present that lends the property to a kind of a rock. For example, a particular rock which is extraordinarily rich in iron, that will always indicate some kind of a magnetic property associated. Okay, any kind of a rock which you will see which is very rich in iron deposits, they will have that kind of a property. Then a unique combination of chemical composition, mineralogy, grain size, texture. Grain size here refers to what? So when you take a look at any rock, you will, if you look at it closely, it will be made up of small particles, right? So that is the grain size, whether those particle sizes are larger or whether those particle sizes are smaller. If ever you would have seen a rock being broken into many different parts or 2 or 3 parts, there also you will find that the particles, they get exposed. So that is the general understanding of the rocks, and they are basically classified dependent upon their formation. That is the broader classification. That is, how is it that dependent upon their classification, the rocks are divided into 3 parts. First is the igneous rock, then you have the sedimentary rock, and then you also have the metamorphic rocks. Now, what are these? So, when we say igneous rock formation, so these igneous rocks, igneous refers to what? Something to deal with fire, something to deal with very high temperature, hence the term igneous. Now, here, whenever there is a volcanic eruption which happens, that volcanic eruption leads to a spread of molten materials, very hot materials, which we refer to as lava. That spreads over to the various areas and eventually they solidify. So the solidification of the molten materials leads to the formation of a rock, and that is the case of igneous rock. Okay. Now here, let's suppose sometimes you can also have a condition. Let's suppose this is the surface here. Now from here, let's suppose the molten materials are coming out and they are spreading out. Okay. Let's suppose the molten materials are getting supplied from an underground chamber where you have all these molten materials accumulated. Now the lava spreads over and it solidifies. So when it solidifies, it forms the rocks. Now, depending upon the chemical characteristic of the lava, what kind of chemicals are present in that, what kind of minerals are present in that lava, that becomes a determining characteristic for the classification of rocks also. Now, other than this, you also have another condition. For example, let's suppose the surface is very hard. Okay, it is a very hardened structure. Now, in that case, the molten materials, they try to come up the surface. But because the surface is so very hard, the molten materials are unable to break through. So, the molten materials, which we know as magma as well, so the molten materials, rather than being able to break through the surface, they will start spreading around and they will solidify in various different shapes and sizes. So here, these molten materials, they have solidified in the interior of the surface itself. They have never managed to break through the surface. In the interior itself, wherever they are present, that is where they keep on spreading and they solidify. So this is also an igneous rock. But here, this kind of an igneous rock is formed in the interior of the surface rather than above the surface. So this is also a characteristic of the igneous rock. So igneous rock overall, if you have to summarize this, are the rocks formed as a result of solidification of molten materials. They can solidify on the surface. In that case, they are referred to as extrusive igneous rocks. And they can sometimes even solidify in the interior itself without being able to break through the surface. Now, I hope we are aware, if we are not aware, the molten materials, when they erupt out of the surface, then they are known as lava. But as long as they are inside the surface, these molten materials, they are also what is referred to as magma. So it is magma which basically emerges out of the surface, and that is the magma. When it emerges out of the surface, then we refer to it as lava. Okay, so this is the case of igneous rock. Now if I ask you a question, that these igneous rocks, will they be able to contain remains of plants, animals, etc.? Will they have the remains of organic matter or plants or animals? What do you think? Obviously no, right? Why? Because it is the molten materials which have solidified. These molten materials might have solidified over anything else, but in the rock themselves, they won't contain any kind of fossils or plants or animal remains. That is why these igneous rocks will always be poor in any of the organic matter whatsoever. Having said that, it can happen over a period of time that when the soil gets formed, soil, basically we will take a look at the formation of a soil at a much later period of time. When you have formation of soil, so soil gets created how? By the breakdown of these rocks. These rocks, they get broken into many smaller parts, and that is how we see the formation, or we experience the formation of soil. Now here, that is why in general, as and when we will take up the topic of soil, you will notice that the soil which is created out of igneous rocks, always they will be very, very poor in terms of their organic matter and the organic content that they possess. So that is the case of igneous rock. Now then, you have the sedimentary rocks. Now sedimentary rocks, how are they created? So basically, whenever you have any new landform which gets created, a new landmass gets created, always it will get created as a result of volcanic action. volcanic eruption will take place, it will deposit these molten materials, will solidify, and that will lead to the formation of the landmass. So, first of all, at any place, igneous rock formations will happen. Now, these igneous rock formations, that is why they are also known as primary rocks. Okay, that is why we refer to the igneous rocks as the primary rocks. Okay, now after this, please write below the images you drawn extrusive and intrusive. Do you have a pen in your hand, my dear friend? Do you have a pen or a paper in your hand? Kindly take up the pen and the paper, and if you feel that there is anything that you can forget, rather than simply sitting and staring at the screen, I would always advise you, I hope you understand, this is not a cricket match that you are watching, or this is not a movie that you are watching through. So take a pen and paper. Please draw those diagrams at your end also if you feel the need of it, and write it down. That will help you revise also. Okay, otherwise you will again come into the category of collector of notes and collector of resources. Okay, right? Okay. Now, here, whenever you have sedimentary rock or whenever you have igneous rock formations, for the first time in any place, you will find that igneous rock formations happen. Now, even in India, when new different land masses were created for the first time, they were basically igneous rock formations. Now, let's suppose you have igneous rocks here. Okay. Now, let's suppose these have come into existence over a period of millions of years. Millions of years we are talking about. We are not talking about a short period of time. Over a period of millions of years, it might happen that there will be streams of rivers, etc., which will come into existence. Streams of rivers, etc., they will come into existence and they will start draining from here. Now, these rivers, streams, everything, rainfall activities, everything, slowly and steadily they will weather down the rocks. They will weaken the rock structure from the area where they are flowing, and they will start accumulating these materials, depositing them somewhere. So, over a period of time, let's suppose here in this area, you have the deposition of materials. You have the deposition of materials. Now, these materials, they keep on getting accumulated. They keep on getting accumulated. Loose materials, they will keep on being accumulated. Now, when they will keep on getting accumulated, they might have plant remains, animal remains, everything being drained by that river. In general, in your life, you would have seen, wherever you would have seen the river flowing, you would have observed that the river carries a lot of these sediments. River carries plant remains, sometimes trees also, sometimes animals also, isn't it? Now they will get deposited somewhere. As they get deposited, one on top of each other, that is the process we know as sedimentation. Because the sediments, as they are known as, these sediments, they will keep on getting piled on top of each other. And think about it. Materials are getting piled upon one upon each other. So here, as the materials, they get piled upon one another, let's suppose, as the materials. So they will impose a weight on the lower layers. They will impose a kind of a pressure experienced on the lower layers. The overlying weight will be imposed on the lower layers, isn't it? So the lower layers, due to that weight, they will start getting compressed. That is a process which is compaction. So they will experience, due to the overlying weight, they will experience compaction. Right? They will start getting compacted, more and more pressed. More sediments will be brought over, more compaction will happen. And you would have seen this around your region also, wherever you are living. Let's suppose you see the soil. Now, if that soil, you keep it moist, you water it all along, the top layer of it keeps on getting moist, and that soil you can dig it out also. But after a point of time, if let's suppose you leave the soil untouched in a region, it becomes harder. It becomes very hard, almost like a rock. So imagine if these sediments are left on their own out there in the nature for hundreds and thousands and millions of years. Owing to their own weight, not only will they get compacted, but slowly and steadily they will start solidifying. And that is when that solidification of the sediments will happen. They will, each of these particles, they will secrete whatever chemicals they have, calcium, sulfate, etc. They will be secreting those chemicals. And let's suppose these grains, they have calcium. If you press them, that calcium will get secreted. That calcium will basically end up sticking with the other particle also. Slowly and steadily, you will have a hardened rock structure, which won't be as hard as the igneous rock itself, but will have a characteristic of the rock. So that kind of a rock, which is formed as a result of that deposition of sediments, deposition over a period of time leads to compaction. Compaction over a period of time basically leads to sedimentation, or rather cementation. Cementation is when they become harder, very, very hard. So I hope we are aware of the English meaning of the term compact. And I hope that compact, cement, that English meaning we are aware of. So they will get compacted and cemented. And that will lead to the formation of a rock type. And that kind of a rock type we refer to as the sedimentary rocks. So when we talk about sedimentary rocks, these are basically rocks formed as a result of solidification of sediments. First of all, deposition will happen, then they will get compacted, then pressed together, then eventually they will harden, and you will have a sedimentary rock formation. Now, will they have the remains of organic matter, that is the plant and animal remains? Will these rocks have the presence of plant and animal remains? What does your logic tell you? Perfect? Yes? So they will consist of the remains of plants and animals, even in our country. You have these igneous rock formations in the region of Chota Nagpur Plateau, that is the region around Jharkhand. Bastar Plateau, that is the region around Chhattisgarh, adjoining portion of Odisha. You have the Karnataka Plateau. These are amongst the oldest regions in our country. Now these were created earlier. Now you had the origin of small streams from these areas, which would deposit materials in between them. That is where, even today, you find the sedimentary rock formations in between these areas. For example, the region where presently river Mahanadi flows, you will have these kind of sedimentary rock deposits which have happened. These are the areas where you even find sedimentary minerals, for example, coal. In between Karnataka plateau and the Bastar and Telangana plateau, there also you'll find these deposits. For example, the Godavari Krishna river where it flows, there also you have such sedimentary deposits which are very, very old, millions of years old. There again, you'll find the evidence in the form of coal. Coal is a kind of a sedimentary rock which gets created due to the trees. Trees, when they fall in a region, they get compressed and pressed over a period of time. That is what leads to the formation and existence of trees. So that is the case of sedimentary rocks. Okay? Is presence of remains only reason why sedimentary rocks have different texture? No. Without river, sedimentary rock is not possible. It is possible. It is possible without the river flow also. Wind flow, wind action, everything can take that into existence. Okay? So that is the case of sedimentary rocks. Now, sometimes what happens, let's suppose we consider a region where you have in this particular area sedimentary rocks. Okay? Here you have sedimentary rocks formation. Let's suppose over the next few hundred millions of years, let's assume there was a volcanic event in this area. And there was such a strong volcanic event that molten material spread over this entire area. Many kilometers thick molten materials, they spread over this area due to volcanic eruption. Now this will again form igneous rock. Now this igneous rock will impose weight on the lower layers, substantial amount of weight on the lower layers. The lower layers will experience some amount of heat as well. So when they are exposed, when the existent rock types, they are exposed to heat, pressure in significant quantity, they simply change their properties, their chemical characteristic, their mineral composition. That undergoes a kind of a change. And that change is what we refer to as metamorphosis. And that is where you will experience the formation of metamorphic rocks. It can happen in the case of igneous rock formations also. Igneous rock formations, let's suppose they experience very high amount of pressure or heat. There also, they tend to change their property characteristic and they form a new rock type altogether. For example, limestone. Limestone, a rock type which you use for the manufacturing of cement, for during the manufacturing process of even iron and steel. Now that limestone is a sedimentary rock. But when that limestone gets compressed over a period of time, when that limestone over a period of time changes its state, it becomes marble. Marble is something that you use for your construction purposes. So marble is a metamorphic variety of limestone. Right? So that is how metamorphic rocks are basically those rock types where the existent igneous or sedimentary rocks, when they are exposed to high amount of heat or pressure, they change their characteristic, they change their type, and they metamorphose into a different rock type altogether. So igneous or sedimentary rocks, when exposed to high temperature or pressure, it gets converted to metamorphic rocks. Okay, that is the basic characteristic. Now here again you will see that, or you can come to the conclusion that the first type of rocks created are the igneous rocks. That is again one of the reasons why igneous rocks, you always refer to them as a primary system of rocks. Now, when we talk about these, the igneous rocks, let us take a look at each one of them now. So first of all, I want you to take a look at the image. The written portion will take a look at it differently. So in the image, what is it that you observe? You will basically observe that there is a uniformity in terms of what are the constituents of it, uniformity in terms of the constituent materials, isn't it? So that tells you that the molten materials or the molten lava would have solidified at one go and would have led to this formation of this kind of a rock. So igneous rocks, they will have that uniform property. Okay. Now, here also, how the cooling process has taken place, that ends up determining what is the size of these individual grains, individual particles that you see. Okay, how that cooling has happened. Why do I say so? For example, let's suppose here you have a molten material, and listen to this carefully. Let's suppose you have the molten materials which are spreading over an area. Now, if the cooling process takes place very quickly, very quickly, it will solidify the molecules, the particles, they will start solidifying in their own place. Right. So the grain size will be very small. The particle size will be very small because individual of these particles, they will end up solidifying almost immediately. But let's suppose if the process of solidification takes place very slowly, so that will give the time for the particles to form bonds and linkages with the other ones nearby. Molecular structures will be created. If the cooling process takes place so slowly, it will give enough time for the particles to form a kind of a bond and a kind of a complex crystal size. Right? So the grain size in that case will be larger. So how that rate of cooling has happened, that will end up determining what is the size of the individual grains. So if cooling happens very quickly, if rate of cooling is very high, individual grains will be smaller in size. If rate of cooling is very slow, of cooling is very slow, then what happens? You'll find size of the particles are larger. Okay, you will have larger size of the particles that you will end up observing. So, when we talk about igneous rocks which are formed on the surface, That is the extrusive igneous rocks. Or when we talk about the rocks which are formed in the interior, as compared to the surface and as compared to the interior, where do you think that the rate of cooling will be faster? On the surface or in the interior? Where do you think the rate of cooling will be faster? Always on the surface. Because on the surface they will be exposed to the outside temperature, outside atmosphere. So always on the surface they will start cooling down very quickly, isn't it? So that is the characteristic that you will also derive in the case of the igneous rocks. We'll take a look into it. So igneous rocks are formed through the cooling and solidification of magma or lava. Igneous rocks may form with or without crystallization. They can form either inside the surface as intrusive rocks, which are also known as, when they start solidifying in the interior itself, when magma starts solidifying in the interior, you refer to it as the plutonic or the intrusive rocks. And when you have the molten materials or magma which solidifies on the surface, they are known as extrusive or volcanic rocks. So that is the case of the igneous rock formations. Okay. Now, then we come to the types. Intrusive, they are formed by the solidification of magma in the inside, and extrusive, solidification of lava on the surface. Now here in the case of intrusive, you will find grain sizes is larger. Why? Because, or grain size rather, is larger. Why? Because rate of cooling is very, very slow. Very slow. So if the rate of cooling is very slow, means what? Means the particles in the molten state, they have enough time to form bonds and structure with the other ones as they solidify. So each of these particles will be able to form crystalline structures, right? Diorite, granite, pegmatite, these are the examples. Pegmatite is the kind of a rock from which you extract mica. Mica is a kind of a non-metallic mineral which you use significantly in the electrical industry, right? So that is the case of intrusive igneous rock. Extrusive, these rocks erupt onto the surface, resulting in very small crystals as the cooling takes place quickly. Basalt, tuff, pumice, they are examples of extrusive igneous rock. So this is the basic classification. There is other set of classification also based upon the mineral present, the type of mineral present, and also the properties that they will exhibit. For example, if let's suppose the content of silica is high and iron and magnesium are less, so that kind of an igneous rock will be lighter in weight also in comparison. Okay, it will be very light. Some of these rocks you will observe, they have the property they can float around as well. They can float on water as well, some of these specific kind of rocks where silica content is so very silica. So many of us, we are unable to identify with silica. So the sand particles that you see, sand particles around you, that is containing silica. Okay, so in general, majority of the rock types that you see around you, the lighter colored rock types, they will be having high silica content. Now you will also find some of the igneous rocks which are very dark, greenish to dark green, blackish in appearance. These are the rock types where they will be very heavy. There the iron and magnesium content will be high, silica content will be low. So based on the mineral component of it, they are further classified into mafic, ultramafic, and even felsic. But we'll not cover it here. We'll cover it when we talk about the chemical composition of lava, which helps us understand the different types of volcanic eruption which happens. That is where we'll cover it. But here also, if I give you the naming of it, so based upon composition, you have mafic, mafic, Ma stands for magnesium, Fic stands for iron. So high iron and magnesium content. Everything in the written format I will give you at the time when we talk about the lava and the chemical properties of lava. Ultramafic, very dark colored, high density rocks. And then the light colored, where silica content is high, felsic. Okay, low density. So these are the various different types of rocks or igneous rocks based upon their chemical classification. Majority of the continental landmass is made up of these felsic rocks. This is one of the reasons why the continental crust is generally lighter as compared to oceanic crust also. So here, that is the case of igneous rock. So if a question is asked, what are the properties or what are primary rocks? What are their properties? Will you be able to write 100 words out of it, 100, 150 words out of it? Will you have the ability to write out of it? Yes? Good. This was the question which was asked in 2022 mains examination also. Okay, so this is the classification of igneous rocks based upon where they have been formed and then based upon the chemical properties. Now we come to the sedimentary rocks. Now when we talk about the sedimentary rocks here, first of all, take a look at the image. Now again, compare it with the image that you had seen in the case of igneous rock, this one. This is of a uniform property, uniformity all around. Take a look at this image. Here you will find various different kinds of materials included. Various kinds of materials included here. What does that tell you? Over a period of time in a region, these materials would have been deposited and they would have been solidified. So sedimentary rocks in general are also considered to be soft rocks, softer rocks. Why? Because they are made up of so many different types of materials, they will have multiple different kinds of weak points, and joints obviously will be weaker. You can break them easily. You can carve it out easily. This is one of the reasons why you will find that majority of the architectural marvels around you that you would have come across, I'm sure all of you would have covered the portion of history in significant detail, and I hope you would have looked at history beyond the fact that who invaded whom, who attacked whom, who killed whom, when, and how great were the freedom fighters. Beyond that also you have studied history. So you would have studied all the major architectural marvels that we have. They are made up of sandstone. Sandstone, be it the Red Fort, be it the Agra Fort, be it the mausoleum of Akbar in Sikandra. Everywhere where you find very intricate carvings, it is made out of sandstone. Why? Because it is much easier to carve intricate designs there, because this is a soft rock structure. If ever you happen to visit the region of in Delhi itself, and in Delhi you have the horse khas village, which was developed at the time of the Tughlaqs. It was basically a kind of a resort summer retreat for the Khiljis, the Tughlaqs, the entire clans of them. Now there, if you notice carefully, you would observe some significant variations in terms of architectural design. You'll find the grayish and whitish structures which were constructed at the time of khiljis, they will have minimal designs, hard rocks, still intact, many of them. And then you'll find during the time of the Tughlaqs, the reddish stone, the sandstone, having very intricate designing. Many of them have been broken down over a period of hundreds of years now. So, the grayish whitish design during the time of the Khiljis, they would generally be constructed out of igneous rocks. That is why it would be almost impossible to carve out designs out of them. But if you take a look at the sandstone structures around them, which were created and carved out during the time of the Tughlaqs, sandstone marvels in terms of the designing work would be observed. Now, this is something that the Turkish invaders they learned over a period of time, and obviously that knowledge percolated, and that is something which was imbibed later on even by the Lodhis and the Mughals when they came. The Mughals, almost all the intricate design work that they did, they would basically use the sedimentary rocks, polished sedimentary rocks. They would polish it so that it could have that same kind of shine, and then that is how they would create the wonderful structures. So these are soft rocks. Now, when we talk about basically the sedimentary rocks, these sedimentary rocks, they are classified into various different parts based upon the fact that how is it that the sedimentation has happened. After all, these sedimentary rocks would be created as a consequence of sedimentation. So based upon how that sedimentation has happened, they are classified into various parts. For example, let's suppose here, okay, by the way, if you have not covered ancient history, modern history till now, please don't, now is not the time to panic. Please concentrate here. I apologize because I mentioned the name of history here. History will be covered. Don't worry about it. Okay? Can we start concentrating now? Because I see many of you panicking, but art and culture is left. It will be covered. Okay, fair enough. Whenever it will be covered, study at that point of time. As of now, can we please concentrate here? Thank you. Now, these sedimentary rocks basically are always created as a result of deposits. But how are the deposits attained in the first place? So let's assume you have an existing rock type. Let's assume you have an existing igneous, sedimentary, metamorphic, any of the existing rock type. Now, being exposed to sunlight, high amount of heat, high temperatures, cold conditions. So, whenever anything is exposed to very high amount of heat, it has got a property to expand. Any material exposed to high amount of heat has got a property to expand. Any material, you cool it down substantially, it has a property to shrink and contract. Multiple repetitions of this expansion and contraction, what will it do to the rocks? It will weaken. Let's suppose rainfall is also happening continuously in that area. It will further weaken. The existing rock type can break, isn't it? Existing rock type can break into many small pieces. They can be carried over and they can be deposited over a region in multiple small fragments. Let's suppose deposited in the form of multiple small fragments. And these fragments then will stack up on top of each other. They will solidify to form a kind of a rock. So this is one of the ways how the sedimentary rock can get created. Then there is another process. For example, if we talk about the formation of rocks such as limestone or iron ore. Now, iron is an element, iron is a mineral, is a material which also comes out during the eruption of lava and magma. We have seen in the case of the mafic and ultramafic, it is rich in iron component. So that is also where you will find iron. But then you will find large iron ore deposits on the surface. That is a result of sedimentary formation. So how is it that iron ore deposits got created on the surface? I'm not talking about the interior. On the surface, how is it that the iron ore deposits got created? So basically, that was an addition. Here, iron ore deposits got created in areas where you had shallow water bodies. Now, in these water bodies, basically the igneous rocks, they had the iron component, some amount of iron component. So the water bodies basically would have taken some amount of that surface material and they would have some amount of dissolved iron, right? But these were not solid particles, but dissolved iron pieces, let's suppose. Dissolved iron pieces in the water. Over a period of time, life evolved. And when life evolved underwater, you had the growth of plants. You basically had the growth of plants underwater. Now, these plants would carry out photosynthesis. In the case of photosynthesis, the plants end up producing oxygen. Now, this oxygen, which would be supplied in water, that would start combining with the dissolved iron. And there, you would have a chemical reaction taking place. That is Fe plus O2 giving rise to Fe2O3. Right? So, this kind of a reaction basically would be observed. Now, this would be in a dissolved state. But when iron oxide would get formed, they would start forming solid pellets and solid particles, and these solid particles would eventually get deposited on the ground surface underwater. These would get deposited underwater. And that is how eventually you had iron oxide or iron ore. Now these deposits or this eventually would also solidify to form rock formations. But this sedimentation has happened why? Because of a chemical reaction. If this chemical reaction would not have taken place, you did not have the formation of iron oxide at all. So these kind of sedimentary rocks, they come into the category of chemical sedimentary rocks. But here also, another example you can take is the case of limestone. Now again, understand that nobody is going to ask you in the examination, tell me how iron ore was formed, tell me how limestone was formed, but always better if you know. So if you talk about limestone, just like iron ore, limestone would also be formed underwater. So in all the areas that you find limestone today, it tells you that the region would have lied underwater at some point of time or the other in history. And here, underwater, you have various different kinds of species, shell-bearing animals. Shell-bearing animals means those who have shells. For example, crustaceans, mollusks, that is crabs, lobsters, snails, all of them, they have a shell, hard shell around them. What is that shell made up of? It is made up of calcium carbonate. Then take the case of corals, the whitish corals that you have. They are also made out of calcium carbonate. Now, when these animals, they die, their body gets decomposed. But what about these shells? The shells will remain. Now, over a period of time, these shells which have been rich in calcium and carbonate, they would form the deposits. One on top of each other. The sedimentation of these shells, corals, etc. would happen. And then they would have solidified. When they would have solidified, they would form that dark grayish limestone rocks that you observe. You find limestone in the region of even Uttarakhand, in the region of Nepal, in the midst of the Himalayas, which tells you the region that we presently call as the mountainous area of Himalayas. At one point of time, it would have been underwater. There would have been a sea. So the sea floor has been uplifted to form the Himalayas. That is why even today in the region of Himalayas, you find the evidence of fossils or remains of animals which have a marine origin. Then limestone is also to be found in the region of Rajasthan, which tells you that in some part of the history, Rajasthan would also have been underwater. That is why in Rajasthan, over a period of time, as this limestone basically gets metamorphosed, it gets converted into marble. Makrana marbles of Rajasthan are quite famous. So wherever you find the presence of marbles means there would have been the formation of limestone there, which means that region in past would have been underwater. But here also, limestone formation has taken place. Why? Because of the enrichment of calcium carbonate and the reaction thereby. So this is again a chemical sedimentary rock. Then, when I talk about, remember I told you that in the region of Indian subcontinent also, you had the Chota Nagpur region, that is the region around Jharkhand, then the Bastar Plateau region, the Karnataka Plateau region. These were created much earlier, around 2.5 to 3 billion years ago. That is when these got created. Now, you had small streams, rivers which would originate from there, and there would be sedimentation in between. Along with that sedimentation, you had phases where mass die off of trees would happen. Plants suddenly would die in large quantities, obviously because of harsh conditions on the land. Now, when these trees with their woody trunks, when they would die, they would get deposited, and there would be further deposits on top of them. These woody materials would get compressed over a period. Now, this is also a deposit of trees, organic matter. These would, over a period of hundreds of millions of years, they would get compressed. Wood is also made up of carbon. So the carbon enrichment would happen. All the impurities would be moved away and carbon would remain. And that would lead to the formation of coal. But that coal, the entire process of formation, is the result of what? Deposition of organic materials and their solidification thereby. So that is a kind of an organic sedimentary rock. When we talk about crude oil, petroleum, natural gas. Now, petroleum and natural gas, how does its formation take place? So its formation is always going to be dependent upon the regions. For example, those areas which at one point of time would have been underwater, under the sea and the ocean. And basically, you had marine animals. When in a same region, let's suppose a lot of marine animals would have died, and on top of that, you had further deposits, and that would have compacted those remains of marine animals without allowing them to decompose completely. Over a period of time, carbon enrichment there also would have happened. And that is where you would have eventually, over a period of millions of years, those remains of animals would have led to the formation of crude oil and natural gas. So even today, in these sedimentary areas, you have the formation or the presence of crude oil. In India, you find the crude oil where? Off the coast of Bombay, or Mumbai rather. You have the Bombay High in the Arabian Sea. So there also that event would have taken place. In Rajasthan, you find crude oil around the region of Bikaner. That again means that region would have been underwater. In Assam, around the Jorhat Digboy region, there also you find the presence of crude oil. that region would have been underwater. In Gujarat, you find the presence of crude oil around the Ankleshwar fields. Again, meaning that region would have been underwater. In the Krishna Godavari basin, you find crude oil. Again, means that region would have been underwater, and a lot of dead remains of animals and plants would have, marine animals would have been compressed. So wherever you find crude oil formation, coal formation, etc., organic materials would have been deposited in huge amount. So basically, we have seen that you have had these kind of formations of sedimentary rocks due to maybe the mechanical weathering and breaking of the rocks in their own place, maybe because of chemical reaction taking place, or maybe because of the deposit of the organic materials. So that is the basis on which the sedimentary rocks, they are classified into three types. You have the clastic sedimentary rocks, chemical sedimentary rocks, and organic sedimentary rocks. Clastic sedimentary rocks, they are formed from the mechanical weathering debris, where a rock has been broken in its own place and would have disintegrated and depositions would have happened. For example, sand, the sand formations, over a period of time when they get solidified, sandstone is created. Silt, silt when we refer to as silt. What is silt? Are we aware about it? So silt is basically the region where, or silt is basically the small sediments that you see the river bringing along with it. Very fine, minute, dark grayish kind of a thing that the river brings along. So that silt solidifies to form siltstone. Then chemical sedimentary rocks. These rocks are formed from the dissolved materials that precipitate from a solution, iron ore, limestone. These end up forming as a result of the chemical sedimentary rocks. Then organic sedimentary rocks are formed from the accumulation of plant or animal debris. For example, coal, dolomites, etc. So this is the basic classification of the sedimentary rocks. Okay? I hope that is understood. At Himalayas, Tethys Sea was there? Yes. If Himalayas were underwater, why there is not petroleum reserves like Mumbai? Because Himalayas, they went through multiple different things and multiple different processes and forces, due to which the that kind of a formation could not happen. Okay, and for how long that region would have been underwater? As long as these deposits would have happened, and then after that, when they would have been compressed, maybe they would have risen above water at that point of time itself, millions, hundreds of millions of years ago. Crude oil available in Iran, Qatar, Russia, these areas were also, at one point of time, these would have been underwater. Okay, so that is the case of the sedimentary rock and its classification. Now, then we have the metamorphic rocks. What are the metamorphic rocks? So when we say metamorphic rocks, these are basically formed by being deep beneath the Earth's surface, subject to high temperatures and great pressure, or even near the surface if they are experiencing very high amount of pressure. For example, in the region of the Himalayas earlier were still parts of Himalayas are composed of sedimentary rocks itself. But in the case of Himalayas, as we will see, the formation, if possible, we'll take a look at it today itself. As this formation happened, there was a huge compression which was happening. The Indian landmass continues to move northwards. Eurasian landmass continues to move ever so slightly southwards. And that is why the fold happens, and that is why the height of the Himalaya continues to increase. But nonetheless, there is a huge amount of pressure which is exerted. So over a period of time, the sedimentary rocks in the Himalayas, they have been converted into metamorphic rocks. Okay, so metamorphic rocks, basically, when you have the existent rock types, igneous or sedimentary, when they are exposed to high amount of temperature, high amount of pressure. Sometimes it also happens due to the movement of the land surface. We'll take a look at it very shortly. Due to the movement of land surface, let's suppose some portion of the land simply goes underneath. Mechanical, chemical, biological weathering we will cover in detail, Mohammed. Please don't worry. This is not the end of the process of weathering. Weathering is in the same region. If a rock type gets broken into various different paths, you have, and if it gets broken due to heat or the action of, let's suppose, the rivers, when they are moving, they are breaking the rocks. That is mechanical weathering. We'll cover it in detail. Okay. So here, let's suppose a landmass goes underneath. The crustal movement continues to happen. Why it happens, where it happens, we'll study. But as this happens, sometimes it goes underneath, and beyond a particular depth, the temperature becomes so very high that the materials, they start to melt. These molten materials, then they rise up. They then lead to volcanic eruptions over the surface. So it can happen that the existing crust can go underneath. So there also, they will be exposed to high amount of pressure. They can get converted into metamorphic. Now, based upon their characteristic, you will find that some of the metamorphic rocks, they will give you a property as if they have been solidified in layers. You will have that kind of a layered appearance associated. These kind of rocks are known as foliated rocks. Okay, foliation basically refers to, for example, onion. Onion you would have seen cut and suffered from the tears due to onion. So onion has got various layers. You peel it out, you have multiple layers. So when you have the rocks having different kinds of mineral composition, when they are compressed, all these minerals, they will form their own different kind of a pattern or banded structure, like bands. Those are known as foliated metamorphic rocks. And sometimes you'll find that the materials, they are distributed uniformly, they get solidified and compressed uniformly. They will give you a kind of a non-banded structure, that is non-foliated, right? For example, marble there. So here, if you take a look at it, there are two types or basic classification of metamorphic rocks, that is foliated metamorphic rocks, non-foliated metamorphic rocks. So these are the rocks. Foliated means they appear in banded structure. They are produced by the exposure to heat and pressure, which makes them appear a kind of a layered structure. They will give them an appearance as if they have various different layers. Phyllite, gneiss, these are the examples of foliated metamorphic rocks. Gneiss is a rock which is generally created as a result of metamorphosis of granite. Okay, non-foliated, uniform appearance. Marble, you would have seen marble. Marble, does it give you the appearance in general, when you take a look at marble, whitish or absolute blackish, isn't it? So that also is what means uniformity. So marble, quartzite, they are example of non-foliated metamorphic rocks. Anjan, do coal reserve areas need to be underwater? Absolutely not, my dear friend. Coal reserve areas do not need to be underwater. Oil reserve areas need to be underwater. Coal reserve areas, wherever you would have had sedimentation of dead trees in bulk, coal would have been formed. I have a very cute question. So I will take that question regardless of whether other questions I take or not. I will take that cute question. And why I say cute, in the sense of all the positive scenario, innocence that is associated here. Why iron ore didn't form rust underwater? So, my dear friend, first of all, please tell me what you understand by rust. The rust of iron that you see, what is rust? Is it that bacteria and fungus comes there and that forms the whitish or that forms that yellowish portion over iron? What do you understand by rust in general? What is rust? Let me know. I will not take your name. Let me know your understanding. What is rust? Rust is basically oxidation of iron, iron oxide. So when you have iron, when you expose it to the outside atmosphere, it reacts with oxygen. The outer surface reacts with oxygen, and then iron oxide is formed. That is rust. But if I am telling you that underwater, automatically you have iron oxide because of oxygen present in water and iron, it will be iron oxide. It is so when you think about iron ore, I hope somewhere in our mind we don't have that preconceived notion that iron ore is that shining iron pieces. People dig it out from the ground, they take it to the construction sites, and they start erecting that iron itself. Iron ore is basically a kind of a impurity of iron, right? From that, you have the smelting process from where you extract that iron. So that is why there is no question of rust getting created in the case of iron ore. Okay, right? How sandstone gets created? Sandstone gets created by the solidification and deposition of sand particles that you see, right? So are you guys forming a group and asking these kind of innocent questions, or these questions are really, I mean, and don't mind, okay, so quartz is also a type of watch and also a rock. How? Okay. So I don't know how to answer this. So basically, when we talk about quartz is a kind of a rock. Quartz is a kind of a mineral. From that, you name a watch, you name your child quartz. Does that mean that quartz is also the name of a human and also the name of the rock? How is it possible? You name anything. Quartz as a rock, as a mineral, that shiny small particle, that is used in watchmaking also. It is from that that you have these particular uh, name which is given, but it is a company. I hope you are aware that it is quartz is a name of a company. All the watches, they are not named as quartz. I hope we are aware of that. Okay, right? Okay. How these layered structures are formed in the foliated rock? Basically, see, when you have various different minerals which are present, various different types of deposits that you have, minerals which are present. Godavari, you have a question, which rock is dominant in the world? So it depends. If you talk about the entirety of the crust and the upper mantle, it will always be igneous, and in the lower portion of the crust, metamorphic. But from one region, for example, in the northern Indian plains, you won't find igneous rock at all. You will find only the sedimentary rocks. So here, when let's suppose Vaibhav, you have the presence of various different types of minerals here. If this rock type experiences compression, it can happen that after a result of that compression, these develop into a kind of a banded structure. That means foliated. Okay. Same condition in both folded and non-folded? No, there is a slight variation in terms of temperature, and the pressure also. Not every place will experience the same pressure. In certain areas, let's suppose pressure will be acting from all sides. In certain areas, pressure will be acting only on two sides. In certain areas, you will also have that on one side pressure is acting at this level, in other side pressure is acting at a higher level. So there will be a variation in types of pressure. That is why. Okay, fair enough. Can metamorphic rocks turn into sedimentary rocks? Absolutely yes. And that is the concept which we talk about in the case of rock cycle. Is the temples were built with igneous rocks? Not all the temples were built with the igneous rocks. You have many temples which have been built with the sedimentary rock formations. Take a look at the earliest available evidence of the temple, the modern day temple, which is the period in which the earliest evidence of the temple is found. Let me test your that kind of a trivial knowledge if you're asking about temples. In which is the earliest evidence, known evidence for the temples? Much earlier than the Cholas also. Do you have evidence of the Harappan temples till now? Random guesswork is going on. Okay. Taj Mahal is an architectural structure. Marbles on Taj Mahal, that is metamorphic. But then inside the brickwork, etc., many of them are sedimentary also. So basically, when you study art and culture in detail, you will find that you have the earliest evidences in the form of during the Guptas, the 5th century AD. You have that is the remnant of the earliest complete structure of a temple. That is made out of sedimentary rock. So temple architecture, both of them you will find. Majorly sedimentary rock formations you will find. Okay. Right, like foliated metamorphic, even sedimentary also have layers. With what is difference? But in the case of sedimentary, it is not always going to be in the banded structure. In the case of sedimentary, you can have a mixture of them together. Here you will observe fixed bands associated. But when you take a look at sedimentary, can you associate any layer here? This is sandstone. Can you associate a layer here? No. Right? Now we come to the rock cycle. What is rock cycle? So basically, we'll talk about it mega slowly. We take it slowly, we'll talk about it. Rock cycle. So an existing rock type, when given with adequate amount of conditions, when provided adequate conditions of temperature, pressure, etc., one existing rock type can always get converted into another rock type. Okay, that process is what is known as the rock cycle. One existing rock type can always get converted into another rock. For example, take the case of metamorphic rock. Metamorphic rock in itself is created how? Maybe an igneous rock undergoing heat and pressure, or a sedimentary rock experiencing heat and pressure. That is how metamorphic rock gets created. But let's suppose this metamorphic rock is exposed to conditions of rainfall, conditions of river action, heating, cooling. It disintegrates, it breaks. It will lead to the formation of sediments. Those sediments, as a result of weathering, erosion, you will have sedimentary deposits. These sedimentary deposits, due to compaction and cementation, will lead to the formation of sedimentary rock. Maybe that sedimentary rock breaks and disintegrates again to form sediments. That can happen again and again. But then it can also happen, for example, in igneous rock, a hard igneous rock structure, that can get disintegrated due to weathering and erosion into sediments that can again get converted into sedimentary rock formations. Or let's suppose the metamorphic rock formations, they eventually they sink underground. As I told you, beyond a particular depth, they will form magma. That magma might rise up and eventually might cool down to form extrusive or intrusive igneous rock formations. Those intrusive and extrusive igneous rock formations that can again move down. Again, it can come up. Recirculation keeps on happening. So each of these rock types, they have the ability to get converted into the other rock type if those necessary conditions are provided. That is rock cycle. So does not mean that if you have an igneous rock, that region will always have only igneous rock. Over a period of time, it can happen that sediments might be deposited over that region, or that igneous rock might have the weathering of that, physical breakdown of that. Sedimentation can happen, sedimentary rock can form over that sedimentary rock. Maybe it gets deposited so much of pressure it can get converted into metamorphic rock. So one rock type can always get converted into other rock type under the prevailing conditions of temperature, pressure, outside forces. That is the condition of rock cycle. Okay. Now, then we talk about, yes, a sedimentary rock can also disintegrate into sediments. Why not? Now we come to the portion which will determine your entire understanding of geomorphology, which is one of the basic key areas when it comes to your understanding of geomorphology. Igneous to metamorphic, my dear friend, how is sedimentary going to get converted into metamorphic? Vaibhav, let me know. How is it that sedimentary will get converted into metamorphic? Are we aware? Just like sedimentary rock, by cementation, it will get converted into metamorphic. No. Metamorphosis is when you have the existing rock types, igneous or sedimentary rocks, when exposed to high temperature or pressure, it gets converted to metamorphic rocks. So either the igneous rock or the sedimentary rocks or the metamorphic rocks, when they get exposed to high temperature and pressure, they change their state into the kind of metamorphic rock. Is that understood? Understood? After igneous rock erosion it's taken away by rivers and by depositing from sedimentary rocks, then to metamorphic rocks. But how it can be returned to the igneous rocks? It gets returned. I will tell you. Don't worry. Wait for this module to get over. Automatically after that I will ask you the same question. You would have understood by that point of time. Wait. Yes, it can take millions of years for formation. So this is the portion which is very, very relevant and important and will lay the bulwark for your understanding of the other portions of geomorphology also. Here, in this particular portion, we are going to cover various different theories. We are going to cover continental drift theory, then convection current theory, then seafloor spreading theory, and then eventually plate tectonics theory. Okay. Now all of these are important for your mains exam. This is the portion which can be relevant both for prelims as well as mains. as well as mains exam. Okay. So, first of all, let me put it very clear. These theories have been provided almost a century back. Continental drift theory was a theory which has been provided almost 100 years, more than 100 years back. Convection current theory was provided in the 1920s. Seafloor spreading theory was provided in the 1950s. And all this led us to the formulation of the plate tectonic theory. Plate tectonic theory is the modern theory, which suits and fits the scenario, which helps us understand what happens on the ground surface. So when you study the continental drift theory, it will have its drawbacks, it will have its lacunae, it will have its limitations. When you study the convection current theory, it won't be able to explain everything. When you study the seafloor spreading theory, it will also have its drawbacks, lacunae, etc. All of these drawback, lacunae, etc., that has limitations. They have helped us to formulate eventually the plate tectonic theory. So when you take a look at the limitations of continental drift theory or the seafloor spreading, please don't judge it with the present day conditions that you see around you, because obviously these theories have not been accepted significantly, but each of them have laid a foundation for our understanding. Maybe a theory is wrong, maybe a theory is not completely correct, but it lays a foundation which helps you understand the world better. That is why you study all these theories, because all of them help the scientists to formulate the plate tectonic theory. Having said that, we start first of all with the basic premise of the origin of continents. What do we mean by this? So, cartography, or knowing the world map, and the ability to have that idea and the image of the world map, that is something which was prevalent for since around 1800s onwards. That is something which was prevalent. But since that point of time, mankind has always wondered that how is it that these continents have this particular kind of a shape? Why is it that the northern hemisphere is dominated by land masses, whereas the southern hemisphere is dominated by the oceans? So that kind of intrigue has always prevailed. That has always been in existence. But in the 1800s, our knowledge of the world was so very limited, it was so very restricted, that basically, when you would take a look at the various different geographers, celebrated geographers of that point of time, all of them, they would postulate a kind of a random concept that, you have more land in the northern hemisphere, less land in the southern hemisphere, because the planet is shrinking, because the planet is cooling down. Mountain formation takes place because the land is cooling down, so there is formation of wrinkles. So there was the entire era of the geographers which we refer to as, we put them into the category of contractionists. They would always adhere, they would always articulate and advocate the contraction of the planet. And they would hold forward the argument that contraction of the planet is actually responsible for the formation of various features of the world. Obviously, they couldn't have been more wrong. But at that point of time, you did not have any competing theory which could provide them correct, or which could basically prove them incorrect. Now, in this backdrop, you have to understand that with the onset of the 20th century, that is in the 1900s, at that point of time, the era of scientific discoveries that reached the pinnacle. Yesterday also we talked about the fact that 1700s and 1800s would be the era where people would go out to different places, they would experience different places, they would have the records of different areas. but the encapsulation of everything and formulation of theories, be it of the universe, be it of the ground surface, be it of the interior of the planet, that started happening in the first couple of decades of the 20th century. The first pioneering theory about the Earth's surface, about the shape of the world, was the continental drift theory. So, that is the first theory that we are going to cover, and then we shall be moving ahead with the other theories also. But before initiating the discussion, I want to take up the discussion in one go. So, we take a break. Take a break for 15 minutes. We'll be back and we will be continuing the discussion. Okay, so take a break for 15 minutes. We come back and we talk about the theories. Okay,